Today in this video we are going to explain how to draw the plan and elevation of a rotated and inclined tetrahedron. We will show you step by step how to solve the question. Let's define what a tetrahedron is. A tetrahedron is a triangular pyramid. It is also a polyhedron, composed of 4 triangular faces, 6 straight edges and 4 vertex corners. This is a 3D model of a tetrahedron that we made on SolidWorks. We made this to help us visualize tetrahedron in different orientations. This is a good activity to do before doing any question, as it helps you to understand the different shapes the object can make when it is rotated and inclined to the horizontal trace. The learning intentions for this question are to 1. Explore the features and construction of a rotated and inclined tetrahedron using auxiliary views. 2. Use previously learned drawing techniques to solve the question. 3. Students will also develop their spatial awareness skills to visualize the tetrahedron in different orientations. Students have previously used auxiliary views to find true lengths, shapes and angles. Some key points of auxiliary views are if drawing from elevation, projected from the plan. If drawing auxiliary plan, projected from the elevation. It's also important to note that you should take point measurements from 2 views previous. So this is the question we will be solving today. There are 4 main bullet points given to us. 1. The plan of the base of the tetrahedron is shown. This is 1 to 2, 2 to 3 and 3 back to 1. 2. Edge 1, 2 of the tetrahedron rests on the horizontal plane. 3. Point 3 is not on the horizontal plane. And 4. Complete the plan and elevation of the rotated object. It's given to us that 1 to 2 is 75 mm. Because this is on the horizontal plane, we know that it's a true length. The first step to solving the question is to draw the tetrahedron as if it's flat on the horizontal plane. We do this by swinging length 1, 2, which is 75 mm, from points 1 and 2, just over point 3, to get point 4. Where they intersect is point 3 on the rotated onto the horizontal plane. This gives us a true shape of the base of the tetrahedron. Next, we must draw x1, y1 line for the auxiliary view. It must be perpendicular to edge 1, 2. We will now get a point view of 1, 2. Next, we must locate the apex of the tetrahedron in plan. We know it must be in the center of the plan of triangle 1, 2, 4. We find the center by bisecting 2 internal angles of triangle 1, 2, 4. Where they intersect is the apex in plan. Then bring the apex up to the auxiliary view using sliding set squares. Then step off the length of the side of the tetrahedron. We know this to be 75 mm. We now have an auxiliary view of the tetrahedron. Next, we must rotate the base of the tetrahedron to its original angle given to us in the plan. We use our compass for this. When the rotated point hits the auxiliary line coming from the original point in plan, that is the point in the auxiliary. Now we can draw the tetrahedron in its proper position in the auxiliary view. To do this, we must swing 2 arcs. Swing length AB from point 4. Swing length B1, 2 from point 1, 2. Where they intersect is a point on the tetrahedron. You can now draw a finish line over the new tetrahedron. Now bring point 3 down to plan. Do this by using sliding set squares. You can now complete the plan of the rotated tetrahedron. Make sure to mark any hidden detail with broken lines. Now we have all info needed to draw the elevation. Bring the points up from plan to the elevation. The lines must be perpendicular to the XY line. We can use the auxiliary view to get the heights of two of the points. Mark these heights using a compass. We are now nearly finished the question. We can now join up the points to complete the rotated elevation. Once again, make sure any hidden detail is marked using a broken line. Here is the finished answer to the rotated and inclined tetrahedron. As you can see, there is no end view. If you would like to develop your spatial and drawing skills more, it would be good for you to complete the end view. Thank you for watching this video on how to complete a plan and elevation of a rotated and inclined tetrahedron. Thank you for watching. Hope you enjoyed.